Graphing lines. So we're going to sketch the straight line that passes through the point 2, -1 and has slope -4, 3. So, a couple things to remember. We have a point here, and when we are looking at a point in our Cartesian coordinate system or in the xy plane, we know the points go x, y. And notice we have labeled our axes here. This is the x-axis, this is the y-axis. Remember, when you're graphing points, plotting points, you are going to use go left or right for the x and up or down for the y. So this region of the graph, just for review, is called quadrant 1. This area over here is called quadrant 2. This is quadrant 3, and this is quadrant 4. So if we're going to sketch the point 2, -1, we're going to start out at the origin 0, 0, and we're going to go right 2. We'll be right here. And then the y value is -1, which means negative means we go down. So this point right here is the point 2, -1. Okay, so just so you can see that, that's the point 2, -1. Now we have a slope -4/3. So let's look at that. Slope can also be written with the letter m. So this is a negative, and then you have a 4/3. Now remember, when you're dealing with fractions, if you have a negative a over b, that's the same thing as doing negative a over b or a over negative b. So we can look at this slope as -4/3, or we can look at this slope as +4 over -3. Because you notice the negative sign is listed in front. We can really associate that negative with the numerator or with the denominator. What does slope do? Well, slope tells us how to get to other points on the graph. So if the slope is -4/3 or 4 over -3, we call slope m is rise over run. Or you could also say it as m is the change in y over change in x. So let's look back here. If we look at m equals -4/3, and again I'm going to make it very clear that negative is with the numerator, -4. So the -4 tells us how far we're going up or down. We're going to go down 4 units. That's what this part tells us. And then this 3 we see here, remember 3 is the change in x or the run. That tells us which direction, left or right, we're going to go. So since it's positive, we would go right 3 units. So from any point we have on our line, we have 1, 2, -1, we can use this process to figure out where other points are. So m equals -4/3 means we go down 4 units and right 3 units to get another point on the line. So we would go down 4, 1, 2, 3, 4, and then we go right 3, 1, 2, 3. This is another point on the graph. We can do it again. We can go down 4, 1, 2, 3, 4, and we can go right 1, 2, 3. There's another point also on the graph. Let's look at this one. So if we look at m equal +4 divided by -3, this +4, remember, still deals with rise or change in y. So the y is +4, which means instead of going down, we're going to go up. So this says we're going to go up 4 units. And this -3 here, again, the denominator is run, or the change in x. So the change in x either to the right or to the left. So this negative says we're going to go left. Say left 3 units. So I can start from any point on the graph. So let's start out with this one down here. I would go up 4, 1, 2, 3, 4, and left 3, 1, 2, 3. I'm at this point that I found earlier. But let's start with this green point, the point I've labeled 2, -1. That was the point we were given. We're going to go up 4. So 1, 2, 3, 4. And now we're going to go left 3, 1, 2, 3. Okay, and we can keep doing this. We can go up 4 again from that new point, 1, 2, 3, 4. And we can go left 3, 1, 2, 3. And we can continue this process. So you can see that we were given 1 point, and we found 4 other points on the line. Now please be careful. That doesn't mean there's only 4 points on this line or 5 points on this line. There are infinitely many points on this line. We just found some that were nice, that ended up with nice integers to plot. Okay, so we're going to connect this with a straight line. I'm going to use a ruler. Okay, so we have a beautiful straight line like this. Let's go ahead and figure out how we would write this. Actually write the equation of the line. So I'm going to scroll down a little bit and we're going to do it down here. Okay, so we knew two things. We know that it passes through the point 2, -1. We also know that the slope is -4/3. That is given to us in the problem right here. Okay, so we have a point and a slope. We can use the point slope form of a line. Point slope looks like this. Y minus y1 equals m times x minus x1. So when you're looking at this, the point is x1 and y1. That's how we're going to label it. So we can plug in each piece. Y minus -1 equals the slope. -4/3 times x minus x1, which is 2. So we've replaced x1 with 2. And we're going to say y1 is -1. So instead of y1, we've written -1. So we clean it up. We have y minus a -1, which turns into y plus 1. And we have -4/3 times x minus 2. Let's go ahead and distribute this. So y plus 1 equals -4/3 x. Okay, then we'll have -4/3 times a -2, but it would be convenient if this was also written as a fraction. Now we're going to clean that up. We have y plus 1 equals -4/3 x. Okay, when you are multiplying fractions, you multiply the numerators and you also multiply the denominators. So -4 times -2 turns into a plus 8, and 3 times 1 turns into a 3. So we have y plus 1 equals -4/3 x plus 8/3. Let's get this into slope-intercept form, so we're going to subtract 1 from each piece. So y equals -4/3 x plus 8/3 minus 1, but we would like to have a common denominator so we can combine the -8/3 and the 1. So this is like -4/3 times x plus 8/3 minus, let's write it as 1/1. The denominator that's interesting is this 3. So it would be nice if we had a 3 in the denominator here. But if we multiply by 3 in the denominator, we also have to multiply by 3 in the numerator. So we have y equals -4/3 x plus 8/3 minus 3/3. Y equals -4/3 x plus 5/3. So this form is called slope-intercept form. Let's look at the graph. If this is in slope-intercept form, remember, is y equals mx plus b. The m is the slope, and b is the y coordinate of the y-intercept. So the y-intercept is 0, 5/3 for this example. So look at our graph. So 0, 5/3. 5/3 is close to 6/3. 6/3 is 2. So 3/3 is 1. So this is like 1 and 2/3. So if you look at my graph, it's off a little bit, but it seems reasonable if this intercept would be 0, 5/3. Okay, so that's one way of writing the equation of the line. You could also write this in standard form if you had wanted to. If you write it in standard form, we want ax plus by equals c. So in standard form, the coefficient of x needs to be positive, and we want x and y on the same side of the equal sign. So we could actually do this in two ways. We could take this part over here. I'll show you. Y plus 1 equals -4/3 x minus 2. And we can multiply both sides by this denominator right here to clear the fractions. So we can multiply both sides by 3. Multiply both sides by 3. So we would get 3y plus 3, because we're distributing, right? This times this. Equals, when we multiply by 3 on the right hand side, the denominator cancels with this 3. So you would have -4 times x minus 2. So 3y plus 3 equals -4x plus 8. Now let's move this x term over here. So we're going to add 4x. Add 4x. When we do that, we see that we get 4x plus 3y plus 3 equals 8. Then we subtract 3 from both sides. We end up with 4x plus 3y equals 5. This is in standard form. We could have also taken this part right here, this equation, y equals negative 4/3 x plus 5/3, and multiplied this by 3 on both sides. If we do that, we're going to get exactly the same thing. 3y equals, well, you're really looking at negative 4/3 x times the 3/1 plus 5/3 times 3/1. These 3's will cancel. These 3's will cancel. So you're left with 3y equals negative 4x plus 5. And then we want to add the 4x to both sides. So we see that 4x plus 3y equals 5. You get exactly the same thing that you got here. So if you wanted to write the equation of the line, you could write it in slope-intercept form or in standard form. Depends on what you're looking for, what the question is telling you to do.